Hello students, so I'm now going to continue the chapter Matrices of 12th standard, and today we're going to learn the method of reduction which is used to find out the solutions of simultaneous, that is linear simultaneous equations. So the steps involved in this method is, the first we have to convert these linear simultaneous equations into the matrix equation, that is Ax is equals to b. Next, by using the suitable row transformation, we have to convert these linear simultaneous equation, that is matrix equations, into the upper triangular matrix or lower triangular matrix or diagonal matrix, or just we have to obtain, that is 1 0 0 in the first column. So these are the 3 to 4 options. And next one, then using the same, you have to use the same transformations in the matrix B also here. Then rewrite the equation in the form of the systems of the linear equation, and by elimination lastly we get the required solution. So for that we just going to solve one example, that is question number 2 from exercise 2.3. so solve the following equations by reduction method. So 2x plus y is equals to 5 and 3x plus 5y is equals to minus 3. So first we have to convert it into matrix form, that is 2 1 3 5. Then we have to write down the variable as it is, that is xy, and then the constant. So we convert it into ax is equals to b, that is in the matrix form. So here we have to use the different row operations to convert this matrix into either upper or lower triangular matrix. So here we use, that is r2. So we multiply this r2 by 2. So by multiplying it we get, that is 6 10. So these changes are in the second row only, in A as well as in B. Next there is a next operation, that is we have to make a change in R2. So R2 minus 3 R1. So R2, so we have to subtract 3 of R1 from R2. So thrice of R1 is 3 2s are 6, minus 6 we get 0. Similarly we have to make a changes here, and after that we get here 7 and minus 21, and R1 row is as it is. So here the, you know, that is the elements, so these are the diagonal elements, and the elements below the diagonal element, if they are 0, then it is called as the upper triangular matrix. So here we get the upper triangular matrix, and now here we have to make a product of these two matrices. So for that the necessary condition is that the number of columns, second one is the number of column from the first matrix, and the number of rows of the second matrix, if they are equal, so I make underline here, that is 2 2 are the same. So we can make a product of these two matrix, and the resultant matrix having the order, that is 2 by 1, that is 2 rows and only 1 column. So how to take a product, that is 2 into x plus 1 into y, and the second one, that is 0x, there is no need to write 0x plus 7y, you can only write down 7y, and the remaining matrix, that is 5 and minus 21. So by equating these two matrices, so we will get, that is 2x plus y is equals to 5, and 0x plus 7y is equals to minus 21, that is 7y is equals to minus 21. So y is equals to minus 3. Now we have to put down this value in this second equation. So by putting this we get the x is equals to 4. So here is the solution of these two simultaneous equation, that is x is equals to 4 and y is equals to minus 3. Now the second example from the same question, that is x plus 3y is equals to 2 and 3x plus 5y is equals to 4. Again we have to convert it into matrix form, that is 1 3 3 5, x y the variables, and the constants 2 4. Now our first operation is R2. So thrice of R1 we have to subtract from the R2. So if we take the thrice of 1, that is 3. So 3 minus 3, here we get 0. Again 3 3s are 9. So 5 minus 9 will get minus 4. Just we have to make changes like this one in A as well as in B. And so finally we get here 0. So we get here the upper triangular matrix. And so by taking the product of these two, we'll get 1x plus 3y, and next one 0x minus 4y, and equals to this matrix. So by equating these two matrices, so we'll get, that is 0x minus 4y, that is you can only write down that is minus 4y is equals to minus 2. So minus minus become plus. So y is equals to 2 by 4. So we'll get y is equals to half. Now we have to put down this value, that is y is equals to half, in this equation. So x plus 3y is equals to 2. So x plus 3 into half. So 3 by 2. So x is equals to 2 minus 3 by 2. So we'll get x is equals to half. So there are total 4 examples in the second question of exercise 2.3. So remaining 2 examples. So you have to solve it. Now we're going to solve the word problems. The question number 3, 4 and 5 is consist of word problems. So the question is, the cost of 4 pencils, 3 pens and 2 erasers is rupees 60. The cost of 2 pencils, 4 pens and 6 erasers is rupees 90. And the cost of 6 pencils, 2 pens and 3 erasers is rupees 70. And so we have to find out the cost of each item by using the matrices. So here we have to consider that the cost of 1 pencil. So there are 3 items: pencil, pen and eraser. For each of these we have to consider 3 letters, that is x, y and z. For pencil we consider x, pen for y, and for eraser we consider it z. So see the first condition, we are given 4 pencils, 3 pens and 2 erasers. So here we write that is 4x plus 3y plus 2z, and the price is total is 60. Second one, 2 pencils, 4 pens, 6 eraser. So 2x plus 4y plus 6z is equals to 90. So taking common 2 from this left side and moving it to right side, so we'll get x plus 2y plus 3z is equals to 45. And the last one, that is the cost of 6 pencils. So 6x plus 2y plus 3 erasers, that is 3z is equals to 70. So here are the 3 simultaneous equations. So we have to convert it into the matrix form. So 4, 3, 2. Second one 1, 2, 3. And the third one 6, 2, 3. And the variables are here. And the last one, these are the constants. So we have to make the different row transformations to make it, to convert it into upper triangular or lower triangular matrix. So the first operation, so we interchange the R1 and R2. So R32 becomes, 432 becomes it is in the first row, so it in the second row, and 1, 2, 3 on the first row. Similar changes we have to make in matrix B. Now the second operation is R2, that is R2 minus 4R1. So there are the changes in R2. So we have to write down R1 and R3 as it is. First we have to write down R1 and R3 as it is. Now see R2 minus 4R1. So R2 is 4 minus 4 of R1. So 4 minus 4. So here we get 0. Next 3 minus 4 2s are 8. So 3 minus 8. So we'll get here minus 5. And the next one, that is 2 minus 4 3s are 12. So 2 minus 12. So we get here minus 10. Similar changes we have to make here. So R2, that is 60 minus 4 of R1. So here by subtracting we get minus 120. Now the next change we have to make, that is R3 minus 6R1. Now the changes in R3. So R1 and R2 we have to write down as it is. And by using this operation we get, that is 0, minus 10, minus 15, and here the change is minus 200. Now see, these are the diagonal elements, 1, minus 5 and minus 15. Now only minus 10 is there, so we have to make it 0. So for this we have to use the operation, that is R3 minus 2R1. So this is R3. If we take the twice of R2, that is we'll get here plus 10. So by adding these two or by taking the subtraction, so we'll get here 0. So here we make it as a upper triangular matrix. Now we are going to take the product of these two. So we'll get here 1x plus 2y plus 3z. Second member minus 5y and minus 10z. And the last one, that is 0x plus 0y and plus 5z. And equals to this matrix is as it is. So there is no need to write down the 0. So you can directly write it like this one, that is 5z. No need to write x, that is 0x. So by equating these two, so we get here the 3 equations. First we are going to write down the single one, that is 5z is equals to 40. So by solving it we get z is equals to 8. Next minus 5y minus 10z is equals to minus 120. Now we have to put down z is equals to 8 in this equation. So by solving this we get y is equals to 8. Again we are going to put down y is equals to 8, z is equals to 8 in this equation. So by putting this value, so we get x is equals to 5. So these are the values x and y and z. So the cost of pencil, that is x is equals to 5, cost of one pen, that is y is equals to 8, and the cost of eraser, z is equals to 8. Now the next question, question number 4. So if three numbers are added, the sum is 2. If 2 times the second number is subtracted from the sum of first and third number, we get 8. And if 3 times the first number is added to the sum of second and third, then we get 4. So find the numbers using the matrices. So here we are given the three numbers. So first we have to consider the three numbers are x, y and z. So from the first condition, what is the first condition? If three numbers are added, so we get the sum, that is 2. So x plus y plus z is equals to 2. Next, 2 times the second number is added, 2 times the second number is subtracted from the sum of first and third. So 2 times the second number, that is 2y, and it gets subtracted from the sum of first and third. So x plus z minus 2y is equals to 8. So we arrange it properly. So x minus 2y plus z is equals to 8. And now the third one, that is if 3 times the first number, so that is 3x, so it is added to the sum of second and third, that is y plus z. So it will get, that is we get 4. So again we arrange it properly. So 3x plus y plus z, we get 4. Here we get the three simultaneous equations. Now we have to convert it into the matrix form. So by converting, we get, that is 1 1 1, that is 1 minus 2 1, and then 3 1 1, x y z and 2 8 4. Again our aim is, that is we have to convert this matrix, that is A, into either upper or lower triangular matrix. So my first operation, that is R2. So we have to convert this R2, that is R2 minus R1. So change in R2, so we have to write down R1 and R3 first as it is. So R1 and R3 as it is. Here also R1 and R3 as it is. Now we have to take the subtraction of these two. So R2 minus R1, so 1 minus 1 0, minus 2 minus 1 minus 3, again 1 minus 1, that is 0. Here also 8 minus 2 is 6. Now the second operation, that is R3. Now we have to make a change in R3. So R3 minus 3 R1. So R1 and R2 we have to write down as it is, same that of this one. Now R3 minus 3 R1. So 3 minus 3 of 1, that is 3. So we get, that is 3 minus 3 is 0, 0. Next 1 minus 3. So then we get minus 2. Here 1 minus 3, again we get minus 2. Here also, that is R3, that is 4 minus 3 of R1. 3 2s are 6. So 4 minus 6, we get minus 2. Now see our conditions in the first part of this lecture. I told you, that is you have to convert this into either upper triangular matrix, lower triangular matrix, or we can form, that is 1 0 0 as a first column. So this is also the necessary condition to find out the equations. So here we get that condition, that is 1 0 0 in the as a first column. Now here we can also take the product of these two. So here we get, that is 1x plus 1y plus 1z. Next one, again 0x minus 3y and plus 2z. Don't write 0 0, you can directly write, that is minus 3y. Next again minus 2y and minus 2z. So this is the matrix of order 3 by 1, and this matrix is as it is, that is 2 6 and minus 2. So by equating these two matrices, so we'll get, that is, just find out the first single term. So minus 3y is equals to 6. So minus 3y is equals to 6. So by solving it, we get, that is y is equals to minus 6 by 3. So we get y is equals to 2. Now we have to put down this value of y in this equation. So we get minus 2y minus 2z is equals to minus 2. By putting this value, that is minus 2, and by solving we get, that is z is equals to 3. Now we are going to put down these both values, that is y is equals to minus 2 and z is equals to 3 in the first equation, that is x plus y plus z is equals to 2. So by putting this value, so 2 minus 2 and z, we get by solving, that is x is equals to 1. So these are the three numbers, that is x is equals to 1, y is equals to minus 2 and z is equals to 3. So this is all about the chapter matrices. The last example, that is question number 5. So this example is for your homework. So this is the end of this chapter, that is matrices. In the next lecture we are going to see the new chapter. Thank you.